Okay, so take a second and think about the building you're in right now. Could be your home, could be your office. We spend nearly our entire lives inside them, but they're hiding a massive climate secret. And the solution to fixing it? Well, it's probably not what you'd expect.
Get this. Our buildings are responsible for a whopping 37% of all global greenhouse gas emissions. Yeah, 37%. That is more than every car, truck, plane, and ship on the planet combined. It comes from the stuff we use to build them, and even more, the huge amount of energy it takes to run them every single day.
Now look, this isn't because architects are evil or anything. It's just the price we pay for being comfortable. All that energy we use for heating in the winter, cooling in the summer, keeping the lights on, it all adds up. And it creates this giant environmental footprint for every single place we live and work.
So, how do we fix this, right? Well, this pyramid here basically shows us the way. Most people, and I'd include myself before I saw this, would think the answer is all that fancy tech. You know, solar panels, high-tech HVAC systems. But look, that's way up at the top in Tier 3, and it only cuts energy use by maybe 5%. The real magic, the biggest bang for your buck, is right down at the bottom in Tier 1, Basic Building Design. Simple choices, like which direction the building faces or what kind of insulation you use, can slash energy needs by an incredible 60%.
So here's the bottom line. The most powerful, most important decisions are the ones made right at the very beginning, on the digital drawing board. It's so much cheaper and way more effective to get it right then than to try and fix a building with expensive retrofits years down the line. Getting that initial design right from the get-go is everything. Okay, so if it's that simple, just design it right, why aren't all our buildings already super efficient? Well, here's the catch. Getting the design right is actually, it's like an impossible puzzle for an architect.
Just try to put yourself in their shoes for a second. You've got to decide how big the windows should be, what kind of insulation to put in the walls, which way the building should face to get the best sunlight, and hundreds of other things. And here's the kicker. Every single one of these choices affects all the others. You change the window size, and suddenly the heating needs change, the lighting costs change. It's a total domino effect.
This creates what's known as a combinatorial explosion. We're not talking about choosing between a few dozen options. We are talking about millions, sometimes billions of possible design combinations. So, how could any single person, or even a whole team of experts, possibly sift through all of that to find the one perfect design? The honest answer, for a long, long time, they just couldn't.
But now, we have a new tool that can crack this impossible puzzle. And it's not some sci-fi robot architect. It's a very specific kind of AI that basically works like a digital building simulator.
The technical term for it is a surrogate model. But honestly, the best way to think about it is like a flight simulator, but for buildings. First, it learns all the complex physics of how heat moves and air flows by studying a few really detailed traditional simulations. Then, once it's learned those rules, it can test thousands of new designs and predict exactly how they'll perform, almost instantly.
So here's a look at how it actually works. Over on the left, engineers will run, say, a few hundred really detailed, really accurate, but also really slow physics simulations. That creates a rich set of data. Then, in the middle, all that data gets fed to the AI model to train it. And finally, on the right, the AI takes over. It uses everything it learned to test millions of different design combinations to find the absolute best one. It's a really smart process. You use a little bit of slow, high-quality data to get incredibly fast, optimal results.
And when I say fast, I mean it's just mind-blowing. A traditional simulation might take 2 or 3 minutes for one single design. The AI model, it spits out a result with almost the exact same accuracy in less than a second. This isn't just a small step up, it is a total game changer. It unlocks a universe of design possibilities that were completely out of reach before.
Okay, that's the big idea. But what does this look like in the real world? Let's actually walk through the whole journey, from setting a goal to getting that final perfect building design.
It really boils down to these 5 main steps. First, step 1, you define your goal. Let's say the lowest possible energy use for the building. Step 2, you generate the data by running a few hundred of those old-school simulations. Step 3, you feed all that data to the AI to train up your digital simulator. Step 4 is the fun part. You just let the AI go nuts, testing millions of combinations in a matter of minutes. And finally, step 5, the AI comes back and presents you with a short list of the absolute best performing designs that meet your goal.
So what kind of AI is actually doing all this hard work? Well, as you can see from the chart, the big winner here, by a long shot, is something called a feed-forward neural network, or FFNN. You can just think of it as a master pattern spotter. It's just incredibly good at seeing those tiny, hidden connections between all those design variables, which makes it the perfect tool for predicting which combination will save the most energy.
You know, the researchers who did this work, they put it perfectly. They said, AI facilitates the exploration of optimal design configurations that maximize energy efficiency. In other words, AI isn't here to replace architects. It's here to give them a superpower, the power to find the best possible solutions that were once hidden in an ocean of complexity.
So, let's zoom out. What does all this tech actually mean for us, for the bigger picture? Well, it means we can finally start building way smarter, which leads directly to a much greener planet.
And here's the main takeaway from all of this. The biggest thing holding back green buildings wasn't a lack of good materials or even money. It was pure, overwhelming complexity. AI cracks that impossible puzzle. It lets us design buildings that are truly sustainable, right from their digital DNA. And this leaves us with a really cool final thought. We've just seen how AI can solve this puzzle for one single building. But what happens when we start applying this to entire neighborhoods or even whole cities? If we can now design buildings to be almost perfectly efficient right from the start, what will our future cities actually look and feel like? Let me know what you think in the comments.